Hi, Sportster Paul here. Another engineering disaster back when I was at Ford Motor. This is Ford Week, I guess. This is the third one. This was the ignition module, under hood ignition module. Let's throw up a picture here. You can kind of see what it looks like. And the first problem is the body and packaging guys insisted that we put it under the hood, mounted on the inner fender, right next to the engine. The electrical group, us in the truck division, we would have rather had it behind the glove box in the cool air of the cab or under the seat, which of course is making the wires really long, and there's problems with that too. But that was too costly for Ford. Let's put it under the hood. So that was the first problem. Then it became, we were worried about it because we knew it had temperature, but it became the worst reliability part in Ford history. If my memory is right, 12 R's per 100, which means 12% failure rate in the warranty period. Now, what I can't remember is the warranty period 12,000 miles, or because it's a pollution part, is it 50,000? But either way, 12% of the vehicles, that's a major disaster. And it all came down to a paper phenolic type of circuit board we used in the module. So let's start looking at what happened. All right, so first problem with this module, it had pigtails. Just like that old 1979 windshield wiper motor I told you about last show. Okay, so the problem with pigtails, same deal. The workers would get behind. You have a lot of high-load vehicles, a lot of options, air conditioning, trailer package, what have you, sunroof. So the guys get behind, so then to catch up, they take like 4 modules in each hand, picking them up by those wire harnesses, and they'd swing back down, throw them on the trucks, and then shoot them as they came back to their station. And that would break the wires in the module, and you've got a no start, which is a very rare thing. It's amazing how few vehicles fail to start at the end of an assembly line, even back then, much less today. So the other thing, here's another shot, another picture. You can see this is the Motorcraft replacement part. You can see it's got a part number 1U2Z, and there'll be an article down in the description that I write, and I'll show you the website that lets you decode that. And pretty much it's a 2001 Motorcraft service part. When I worked at Ford in 1980, these kind of parts would be EOTB. EO was 80, E was the 80th decade, O is 1980 pickup truck. That's for when it's released, not when we're working on it. T is the truck division, B is BEPE, Body Electrical Product Engineering Division. So that's who had the design responsibility for the part. Okay, here, let's shoot up a picture. Here's the underside of that Motorcraft service part module, very similar to the original module in 1980. You can see it's potted. They put the board inside of it, then fill it up with potting to seal everything, humidity. It's an epoxy potting, really tough. Then the wires come out and can go to a connector, and then the connector goes to those stupid pigtails. Modern modules aren't like this. You notice the connector's right on the side of the module, and a lot more pins because things were a lot more complicated. So the potting became the problem. Let me show this picture. This is a paper phenolic circuit board, okay? This isn't the modules board. This is just something I found for free on the internet. But it's that whitish color. You see it a lot in appliances, your stove, your washing machine. It's dirt cheap, which is why Ford loved it, right? All the finance whiz kids who were ruining the company back in 1980. They loved that it was cheap. But it's paper impregnated with phenolic, a thermoset plastic, but it's not that strong. So what would happen now, the module's under the hood, it's temperature cycling as the engine goes on, you drive around, hot, cold, and it would crack that board. And then it would expand out, it expanded towards the potting, if I remember right, and the circuit board trace, one of them, all you needed was one, would open up microscopically, and that's it. Your car died on the side of the road. And, Ford is decent people. They know that's a horrible, we had classes of reliability problems. If the thing ran poorly, that's why we put it in stumble idle when there was a pollution problem. You could get home at least, right? We weren't going to strand you out by the side of the road. But this failure stranded you by the side of the road. And what was insidious is, open the hood, mess around, poke around, the module cools off, those little traces touch again. You're like, I don't know what's going on. You try to start the car starts. Maybe it'll go another day, another month. All right? So that was the fundamental problem that we had. So let's look at the way I wanted to fix it and the way they ended up fixing it. All right, so shoot this picture up. This is an FR-4. FR4, some people think it means fiberglass reinforced. Actually, it means flame resistant because it's made from fiberglass with an epoxy, and it's much stronger. And because, the flame resistance is because that paper you could burn. If you got those paper phenolic boards on fire, you could sustain flame in certain cases. I said, well, it's an easy solution. Just change the board. Use the same patterns, the same Gerber files, just change the board. Unfortunately, that would have been like $1 or some insane amount of money. And Ford, the management said, we make 6 million of these a year. And no engineer is going to cost us 6 million and save his job, much less the entire department. So that was out, and I kind of knew it would be. What they ended up doing, at the time I thought this was Mickey Mouse, but now I think it was pretty smart. They took it's zinc, I think, a die-cast housing. They poured sand in, half an inch of sand, laid that paper phenolic board on top, and then potted it. So now the potting's thinner, and that sand, it's got some air in it, it's got a little cushion, solved the problem. I can't remember what the new reliability figure wasn't that great either, because it is under the hood, and we knew that was going to be a problem. But at least it wasn't, horrific. So they fixed it that way. And in fact, because sand is cheaper than potting compound, they were able to book a cost reduction. And, I just thought it was Mickey Mouse at the time, but now with all my experience, it's like, that was a pretty smart way. Save money and fix the problem. So that's how Ford fixed it. In fact, here's an aftermarket module for the Ford, but I'm not sure, if it fits the exact same truck. But you can see from the potting, the little graininess, you can almost see sand in there. But the important thing to remember is we didn't mix the sand with the potting. We laid the sand down, put the board on top, poured the potting over. And that gave the kind of springiness and cushion that let the part live, all right? All right, throw this picture up. This is a aftermarket, not a Motocraft, which is a little more a real Ford part. This is an aftermarket module, and I noticed that it's got fins on one side and it's smooth on the other. And that might be a real smart way. The big power transistors fire in the coils, you put that where the fins are because the heat's coming out. But the rest of it, the engine compartment's hotter than the board. So they made that smooth so there's less heat transfer into the module. So that might be a clever way that they worked around it, all right? Here's that same aftermarket module. Here's the underside of it. And you can see how they just kind of fill it up with potting. It just fills up like a swimming pool. Interestingly, you see there's also a little distance between the top of the potting and the edge of the thing. Years later, I'd quit Ford because of some of these problems and went to Silicon Valley. I met a technician there at a military contractor. I think he had a Capri or a Mustang or something. It died by the side of the road. He'd already figured out it was the module, right? He kind of knew something was wonky with the ignition module. So it died, stranded him on the side of the road. He gets out of the car. He knows he's got to open the hood, let things cool down. And he looks around and he sees one of those drunk bumps. One of those yellow reflector highway things they put in the lanes so bump, 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 you're drunk and you're leaving the lane. So he gets the broken drunk bump off the side of the road, he's got tools, he's a tech, unscrews the module, sticks the drunk bump under it, and then screws it back down. And, the drunk bump was a little bit thicker than that relief in that picture we just saw. So it squeezed and pushed that circuit board and closed up the trace, jumps in the car, starts it. He ran the car for 5 years like that and sold it, still working. So that's the kind of quality people that you love to meet out in Silicon Valley, all right? Okay, speaking of Silicon Valley, years and years later, I ended up working at Teledyne on high voltage power supplies for traveling wave radar tubes used in the pods underneath an F-16 fighter jet that would broadcast radar to screw up the missiles coming to shoot you down. And they were experts. They not only potted stuff, they vacuum potted it, where you put it under a vacuum and any little air bubbles inside boil out. And it was finally there that I learned that there's a fundamental trade-off with potting, okay? Hard, stiff epoxy, you mix it like that, formulate it like that, it transfers heat really well. So it gets the heat out of all those components out to the housing and somewhere away, right? Problem is, because it's so strong, it will break components. We could thermal cycle them some of these parts, and it would actually rip the wires out of the end of those big diodes. And these are hermetic glass diodes, right? So then the trade-off is you could go to a more of a silicone, rubbery kind of epoxy. It would give a little as the board cooled and heated, but it wouldn't break the components. Or in the case of Ford, it wouldn't break the board itself. There was a technician I worked with at Teledyne, and he said he could do the military spec temperature shock cycle, minus 125 degrees centigrade to, plus 125 degrees centigrade down to minus 55, and then back up to room temperature. He said he could do that 5 times and break anything that any engineer dreamed of. So that's the headaches putting stuff inside cars, right? Put it in the engine compartment. It's a brutal environment. Not only do you have the heat and the temperature cycles and the outside temperature and the temperature being made by the module itself, you've got vibration. And I think a little bit more in the inner fender of the engine, or on the engine, even worse, compared to behind the glove box under the seat. So that's the Ford disaster for today. Stay tuned. We got more coming. Sportster Paul, catch you later.